Good morning, and I mean very early morning. I'm going to go through a couple drawings I've got set up here that have some names like AutoCAD exam reactions and other path, which I will eventually provide to you. I already had these drafted and provided them to you for this exam, and then I provided paper, and you need to start seeing how you need to be able to work in both systems pretty efficiently. Someone asked the other day, a student who's not a civil student, why are people working on paper? And I kind of looked and shuddered. And I don't know how much people think it's just computer, but when you're provided a computer file, yep, it's probably the best thing to work on. And here's how we're going to do it. I'm going to go ahead and use some tools like freeze layers and kind of get started with the way the drawing was probably provided to you. Now I have to set my current layer. If you're usually used to that, I want to set my current layer to something that as I'm freezing through, I'm not going to freeze. So when I go ahead now and freeze this out, in all reactions it probably looks something like that. It probably did not have that. Didn't have the reactions there, but if you look at here, this is the problem this is given. And I've talked a little bit about divide and slide and slide and divide, and I think hopefully by now you all realize that this could just be solved by a moment problem. If in fact I did an ID on the end of this, if I set my UCS so that was 0, 0, 0, it'd make things somewhat easier. So I could do that, UCS new, and then just my new endpoint would be there. Therefore, if I wanted to get list or use like you've been doing the pull downs, I'd list that. It tells me where this is starting from. It tells me it's delta. Therefore, I can calculate a moment. I can do the same thing, ID from the endpoint of this. And all of a sudden, I know what its radial vector is 20. So I can take force times distance equals force times distance. I have a calculator. I could write it down. Eventually, that's what we'll be doing automatically. But let me just go ahead and start showing you the couple of different ways. I'm going to turn everything on. I will point out that as you go to an older version, save as an 04, all your layer states are not saved. So that's one thing that's not back compatible. We'll need to look at that if you're working not in AutoCAD 2010, minus layer thaw, star, on, star. And I'm going to go ahead now and freeze out some of the automatic table stuff I've got in there. And I'm going to actually just first show you the other path, because the other path basically looks something like this. You slide, you divide, you measure the arms. You slide, you divide, you measure arms. But that is not the most efficient way to do this problem. The most efficient way is R cross F equals R cross F. And so I'm going to now go minus layer thaw, star, on, star. And once again, freeze out. In all reality, there is no point in sliding, no point in dividing. You had this force here times this distance. If you think about your spinny point here, this force is turning at this distance. It's R cross F has to be equal to this force times this distance. So you take this distance here, this force, and this radial arm, this moment arm, and this force, you multiply them together and you divide by 20 and you get that. Do the same thing here. You take this radial moment arm, this moment arm, and this force, you divide it by 20 and you get that. In the end, you also have to realize that this is going to have a component going this way and it has to be reacted all to at that X joint. So that's how that first problem is done. It does remember, however, when you go to an older version of AutoCAD, it does remember your views. It's been around a while. Views have been good. I'm going to go to problem 2 here. Problem 2, force times distance equals force times distance. And of course, you end up knowing that all of the Y has to be on here and all of the X has to be on there. The slide and divide didn't make much sense there. It's all R cross F. Problem 3. Let me go ahead and turn everything on. Minus layer thaw, star, on, When I provide this file for you, there will be layer states. So let me go ahead and freeze. So there'll be layer states that take you through 1, 2, 3, and 4. Let me freeze that. Those are my moment arms. So you start with this idea of knowing where the centroid and area underneath, having a resultant. And then in the end, you just have a force here. You slide. Let me see if I can show you how the layers are set up. Hopefully I can. Divided. I'm going to go ahead and turn up that slide and divided. So now you've got, you slide, you divide, you measure the arms. In other words, this 4.37 is, for this support here, it is 20 feet away from the other support, and these supports are divided by 8.348. So it's going to be more, this is going to react to this force with more. It's about 2.5 times that. This is going to be reacting back because distance from the other support is going to be this distance out here divided by the distance between the supports. There's going to be a negative involved. So that's what that looks like when you do a slide and divide. Your reactions start to look something like this, very small on that end. However, if I do minus layer thaw star on star, this is what it really looks like if you're going to do the true calculation. Force times distance. In other words, this force times this distance equals this force times this distance. And then in reverse, this force times this distance equals this force going up times this distance. And you can realize there that that becomes pretty small, because you also have, you end up with, you see how these distances are very simple. Force times distance here equals force times distance. This is actually a negative, so it's not showing correctly. It's coming back down. At the same time, you have force times distance and force times distance for the value coming down. I'm going to continue for the next 3 minutes. I'll do this next bit when I've got the file actually working. This is not, without having the layer manager set up, it does not flow as smoothly as it's supposed to. But you do have that when you get the drawing delivered to you. There's problem number 4. That one I'm not going to give much merit to. Area underneath, force times distance equals force times distance. No slide, no divide, no real thought of moment arm. This one here, again, you can see, I'll leave them both on. You can slide and divide, but in reality, you can just do force times distance equals force times distance. In other words, this force coming down here at this distance equals this force times distance. Once again, probably easier in CAD coming in here and just changing your user coordinate systems to something, turning it, spinning it, and then using the radial vector thing. Because if you set your coordinate to 0, 0 here, then when you list a vector, it will have both the radial arm, which would be the location of the initial point of your vector, and then the delta will be the force vector. There's even no reason necessarily to do a lot of dimensioning when you're using this combined system of CAD and math calculator. That's problem 6. Again, very similar. Problem 7. Again, we can do the slide and divide, take it down here, but it makes more sense of going force times distance equals force times distance. Force times distance equals force times distance. So usually that second distance is the distance between the supports. However, you notice here I didn't slide this down. You can slide and divide. You're going to need to know when each one is efficient, but you really need to look for as much as you can when you have CAD at your disposal to look at the moment. And even to the point where you step in and don't even do the drafting, you just start pulling off some coordinates and throw them in a matrix. 7, 8. Again, once you get the area underneath and get a centroid, that's just basically a weighted average between the two, distance from this other support, distance between the supports. Same thing for this one. And then again, this little tiny force. Force times orthogonal distance equals force times orthogonal distance. You add them all together. The last two I won't give much merit to. I'm going to run out of time here. You've got to split this into two problems. One I've talked about before, and the other one is just splitting two ways. In other words, this is spinning this way. This has to spin opposite based on a ratio of the distances. You have to figure out the rest. And then finally, problem 10. Force times distance equals force times distance, and then you got to do some more with that. So that's the first time through with these. I will provide eventually, once I've seen you've submitted something, and then I will take a retest on this from most people. We'll see how long you should get for the retest. Some people have got it done it well. In the end, you need to check that you've done your correct things by sum of forces equals 0, sum of moments equals 0.